The section today is section 3.6, which is titled Implicit Differentiation and Related Rates. Now I'm splitting this into two parts, calling it section 3.6a, and part A will just cover implicit differentiation. So before we get started with the calculus part of it, let's look at the word implicit. What does it mean in English? What does implicit mean versus the word explicit? So the word explicit might be easier to think about its meaning. Explicit means something that is more direct, okay? Whereas implicit is implied, that's the root word there, or something that is sort of subdued, you know, it's not as direct, it's a little indirect. So far the functions that we have seen and the derivatives that we have taken have been of explicit functions. So where y was directly in terms of x, y was in terms of x. Meaning we had something like y equals x squared plus 4. And we were able to differentiate y prime as 2x. But in implicit differentiation, you're going to not have y solved for. Rather, you would have y squared x squared plus 2xy plus y cubed x equals 10. Something like this. This is an implicit equation where y is still a function of x, but it's not solved for. Okay, so it's all buried inside there. So how do you find y prime? Okay, for an equation like this, how to find y prime? First of all, at this point it gets easier if you use the notation for derivatives rather than y prime, but use dy dx. The meaning of this notation is you're taking the derivative of y in terms of x. Okay, so that's what we're doing here. So to get used to this idea, using this notation, we're going to do the first worksheet, the warm-up sheet. So let's get to that. It should look like this. So the first question is, if x is t squared plus 2t minus 1, find dx dt, the derivative of x in terms of t. Well, x is in terms of t, so this is a direct problem. Dx dt, the derivative is just 2t plus 2. The derivative of 1 is 0. Over here we have y in terms of t. So to find dy dt, excuse me, we're going to first rewrite t to the 1/3, and then we'll get dy dt is 1/3 t to the negative 2/3. So far so good, nothing different. Over here we need dy dx, the derivative of y in terms of x. Well, y is in terms of x, so that's easy to do. Dy dx is just 2x. Now to get a little bit closer to our understanding of implicit differentiation, we're going to start writing our derivatives as follows. What is the derivative of x to the 5th in terms of x? Well, that's just again straightforward. It's just 5x to the 4th. So the variables here match, so it's pretty straightforward. But in the next question, you have the derivative of y to the 5th in terms of x. Here the variables do not match. Okay, they don't match. Not same. So when you take the derivative of this, you're going to use the chain rule, because what is implied here is that y is a function of x. Okay, y is x cubed plus whatever maybe, the whole thing raised to 5. So when you take the derivative, it's 5y to the 4th times, then you go inside and do the chain rule, and you get the derivative of y with respect to x. Okay, so for example, if y had been x cubed plus 8x, and you had y to the 5th, it would have been x cubed plus 8x to the 5th. So if you needed the derivative with respect to x, what you would have done is bring the 5 down, this raised to 4, and then you would have gone inside and taken that derivative. Okay, but we don't know what y is. That was just an example. So what I'm saying is, in general, the derivative is 5 y to the 4th, this is y to the 4th, times, you go inside, take the derivative of y, and that's this piece added in. or multiplied rather. So let's try to see if we can make sense of this with one more problem. Here we have a sum of two terms. So think of this as a sum rule. It's a derivative of x squared in terms of x and derivative in terms of x of y squared. So here the variables match, so the derivative is straightforward, 2x plus, but here they don't match, no match. So the derivative is going to be 2y dy dx. Okay, so if you prefer to use y prime here you can, but it's not very clear as to what y prime represents unless you say it as dy dx. Okay, now let's do a full-blown problem where we have an equation, an implicit equation. We need to find dy dx by doing this process. So what you have to do is introduce the derivative here somehow. So since you have an equation, this is a legal step to do, and that is we differentiate both sides with respect to x. Okay, WRT is with respect to x. So if you're using the notation, what we're doing is we're doing d dx, the derivative with respect to x of the left hand side, and that's equal to the derivative with respect to x of the right hand side. So over here when you have the sum rule, you take the derivative of the first piece plus the derivative of the second piece. So it's d dx of the first plus the derivative with respect to x of the second. On the right side, the derivative of 1 is 0, so let's just do that and get it done. Now over here you have a product, so you have to use a product rule. The product rule states that you take the derivative of the first, and that would be 2x, keep the second as it is, plus keep the first as it is. Now do the derivative of the second, but here the variables don't match, so when you take the derivative you get 3y squared dy dx. Plus, so we're done with this piece. Over here the variables don't match, so when you take the derivative it's chain rule, 2y dy dx equals 0. Now we need to do some cleaning up, like all this can be written nicely. This is 2xy cubed plus 3x squared y squared dy dx plus 2y dy dx equals 0. Our goal is to find dy dx. So what I'm going to do is, this term does not have a dy dx, it's going to go to the other side. Send it over to the right side. And then on this side, dy dx is in two spots. We're going to factor it out. So you have dy dx times 3x squared y squared plus 2y equals negative 2xy cubed. And then finally divide, and then you solve for dy dx. So divide both sides, and your final answer, dy dx equals negative 2xy cubed divided by 3x squared y squared plus 2y. So again, the answer is different from how it used to be, because in the past dy dx was all x's here, but we still have y's in it. So if you're trying to find the slope of a tangent line, you'll need both x and y values to do so. On the next page of this worksheet is one more problem where we have to do something like I just mentioned, find an equation of the tangent line to the graph of the function f defined by this equation, x squared minus y squared equals 9. So supposing we have this equation, differentiate both sides, differentiate, I'm abbreviating, both sides with respect to x. The left hand side, the derivative, writing d dx of x squared minus y squared equals 9. D dx of 9, So first, subtraction rule, the derivative of x squared in terms of x is just 2x. The derivative of y squared in terms of x is 2y, but the variables don't match. Chain rule, dy dx. Right side, constant's derivative is 0. Now we solve for dy dx by subtracting 2x from both sides. So you get negative 2y dy dx equals negative 2x divide by -2 y on both sides to solve for dy dx. The -2's cancel out, so you just get x over y. So this is the derivative, and we need to find the equation of the tangent line at that point. So at 4 comma root 7, the derivative, so x is 4, y is root 7, so there's a slope. This is m of the tangent line. So to find the equation, it's y minus y1 equals m times x minus x1. This is our point, so it's y minus root 7 equals 4 over root 7 times x minus 4. And there we go. That's the equation of the tangent line. Now going back to my notes that I had before, I had made up a problem right here, and I want to actually finish that up. If we need to find dy dx with this question, how would we do it? Well, we do the derivative on both sides with respect to x. So I'm going to do d dx on the left hand side, and then the derivative with respect to x on the right hand side. On the left side, I'm going to put a dot here to remind me that it's a product, a dot here, product, another dot there, product. Okay, so when I do the first one, y squared, the y doesn't match the x, so the derivative is 2y dy dx plus, times x squared. Remember the product rule, the derivative of the first, keep the second, plus, keep the first, the derivative of the second. This variable matches this variable, so you just get 2x. So I'm going to put a check. We're done with that term. Moving to the next term, 2x times y. Take the derivative of the first, you get a 2, the x's match, and then keep the y as it is, plus keep the 2x as it is. The derivative of y is 1, but it's y, it's not x. It doesn't match it, so we need a dy dx. Okay, so we're done with this. Okay, moving to the last term, the derivative of y cubed is 3y squared. Keep the x as it is. But wait a minute, we just took the derivative of y, so we need a dy dx right there. And then we're going to write the x as it is. Plus, keep the y cubed, take the derivative of x, you get 1. Right hand side, that's the easy part, the derivative of 10 is 0. Now cleaning up and condensing all this, so this is one term. I'm going to put all these stray terms together, 2x squared y, 2x squared y, putting 2x squared y together. And at this point, if you want to use y prime, if it makes it easier, you can. And this is 2x y squared plus 2y plus, that's condensed as 2x y prime. Over here, put these terms together, and you get 3x y squared y prime plus y cubed equals 0. Now the terms that I am underlining are special because they all contain y prime, y prime, y prime, y prime. These other terms that I'm putting squiggly lines underneath, they don't have y prime, so they're going to get sent over to the other side. Go to the other side. These three that I underlined with boxes, while they stay on this side, factor out the y prime, because that is what you're solving for. So you get 2x squared y, this is gone, right here, plus 2x plus 3x y squared, and that's gone. So let's put all those terms here, they're all negative, so it's negative 2x y squared minus 2y minus y cubed. And one last final step to get y prime by itself, it's being multiplied by all this. We're going to divide that term out, and then we will be done. So there's a little bit of writing in these questions, but if your algebra skills are good, you can skip a little bit and make it a little more concise. Okay, so that's implicit differentiation. I highly recommend that you look at some of the questions, examples done in the textbook. Let me see if I can get it to show up under my camera. So if you go to page 222, there's example 1, y squared equals x, find dy dx. The work is shown here. And on the next page, there's a more complicated question. This is similar to one of the examples I did, but read these examples, and if you have any questions on the homework, be sure to contact me, as always. So example 4 has product rule in it, and so on. Okay. Alright, that's the end of this section.